everybody, this is Mr. Walsh, and today we're going to be discussing how we classify matter. If we're going to talk about how we classify matter, we should set up some ground rules for definitions. So make sure you have these definitions in your notebook. But matter is anything that has mass and takes up space. And if you notice, we have mass, and we have takes up space, which is volume. And we just got done a lab and some learning about mass and volume. And so that's anything that has density. So that's pretty cool, right? Okay. I mean, not like cool, I'm going to go post it on social media sort of cool, but cool enough. And then the first two things we're going to talk about is substances and mixtures. So substances is anything that's made up of only one type of matter, so it's only one thing. And a mixture is a combination of two or more types of matter. So if you need to write these down, just pause the video and take a minute and write them down. We're going to play a little yes or no game. Okay, so the idea is, are these things matter? Okay, is light matter? Well, of course I start with the one that's trickiest here. Chemically speaking, light may or may not be matter, but here's what I'm going to say. Unequivocally for this class, we're going to say that light is not matter. No, it is not. Okay, an apple, does it have mass? Does it take up space? Sure does. So yes, an apple is matter. How about a thought? A thought doesn't have mass. And while thoughts matter, it doesn't have matter. So a thought is not matter. Okay. And then paper is matter. Okay. Space, volume, mass. Okay. So then substance or mixture. So the way that I like to think about it is a mixture has ingredients or different things that make it up. Okay, so a couple of things that don't seem to right off the bat have ingredients but do are things that come from living cells. Okay, living cells all have ingredients. The endoplasmic reticulum and the phospholipid bilayer and the cell wall and the membrane and DNA and all that stuff. So living cells, no matter what, they have ingredients to it. On top of the things that we normally think of having ingredients, like when you bake or cook, you put a steak in the oven and you put, that comes from living things, but you put seasoning on it or chicken and you put barbecue sauce on it. All those things have ingredients, okay? So carbon is a substance. Okay, carbon has just one thing. It's on the periodic table. Okay, so because it's on the periodic table, we know that it's only one thing, and it's a substance. Muffins, we know that muffins are made with ingredients. Okay, so that's definitely a mixture. Now, when I put this pure water thing here, pure water is H2O, and that is just one thing. It's two elements, but those elements are bonded together, and so this is a compound. Okay, and compounds are substances. And then the last thing, paper. You may wonder, what's paper? But paper is made from wood. Wood is made from living cells, so that's a mixture. So there are two types of substances. Okay, again, you're probably going to want these definitions written down, so I would definitely pause the video and write them down. But an element can't be broken down into smaller substances, but the thing that you're going to want to know is that it's always found in the periodic table. Okay, there's 118 elements, and that's it. Okay, now you can tell if it's an element because if I'm writing HE, it's a one or two letter symbol, but the first letter is always capitalized. Okay, and if it's a compound, now we have multiple elements, but they are combined together. So and you can tell because it'll have multiple capital letters when we put its symbol down. So we have something like water, H2O, capital. That means it's two elements, chemically combined. Or we may have NiCl3. Okay, capital letter, two elements chemically combined. This is a compound. Look here, and it's nicer when it's colored, but if you look, here we have one type of atom. Because there's just one type, this is an element. Okay? The same thing is true here. One type. This is one type. And so this still is an element. Okay? But now if you look here, we take this and we bond it together with a different type. So these are two different elements, but they are bonded together. Okay? So we have this darker element bonded to this lighter element. Okay? So this is a compound. So you can kind of see the difference between an element and a compound. One type. This is all just one type of thing. This is all one type of thing. But then when we mix them together and they react, you get this, and you have one bonded to a different thing, and that makes it a compound. So let's play the game again. Okay, you're going to see pure water here a lot. Okay, carbon dioxide. Okay, carbon is on the periodic table, oxygen is on the periodic table, but here carbon dioxide bonded together, so this makes a compound. Okay, gold. Okay, gold is on the periodic table, that's an element. Hydrogen on the periodic table, an element. Pure water, again, that's the example that I've been using. Pure water is H2O. Okay, two elements bonded together, that's a compound. Last thing is the different types of mixtures. So we have heterogeneous and homogeneous. Okay, now again, you can write down these definitions. All you need to do is pause the video and get them down. You may already have them down. But a homogeneous mixture, I'll start here. A homogeneous mixture is what I call smooth. It is consistent throughout. It has the same texture throughout. It is smooth. A heterogeneous mixture is something that I call chunky. So you can see the parts, you can see the pieces. It has different textures. So that's kind of the difference in the way that I can tell you how to know. Like if you can see the parts, or if it looks chunky, or if it feels chunky, that's good. Okay. Now the other thing is that you may see the term solution. A solution is a homogeneous mixture. Okay. And this is a solid that has been dissolved into a liquid. Okay. So something like salt water. Okay, salt water is a solution, but it's also a homogeneous mixture because the salt completely dissolves. Okay, so a solution is a special type of homogeneous mixture. Here's my example. We have a bowl of cereal, okay, and you can see the parts. You have the milk here, you have the flakes, you have the little fruits. Okay, you can see the parts. This is chunky. So if it's chunky, this is a heterogeneous mixture. Okay, but here's a cup of coffee. Okay, even if you put cream and sugar in here, it's consistent throughout. There's not chunks in your coffee. Okay, and I'm not trying to be gross, but I'm just trying to tell you how it works, right? So that is a homogeneous mixture, or you could call it a solution. So now we play the game again. Gasoline. Okay, gasoline is a mixture, but is it chunky? Okay, like when you pump gas, does it come out in pieces? Is it like a salad? No, it's smooth. It's different. You can see the parts, or you can't see the parts. Okay, peanut butter and jelly sandwich. Okay, you have bread, you have your peanut butter, you have your jelly, you have another layer of peanut butter, and then you have your bread. Okay, you can see the parts. Even if it's kind of mixed up, you can still see the bread separate from that. The bread itself, has parts that you can see. It has the crust on the outside. So this is definitely heterogeneous. A salad is chunky. You can see the parts. You can see the lettuce and the tomatoes and whatever else you put in your salad. So that's going to be heterogeneous. And then we use the example of salt water, okay, just on the previous slide. So that is homogeneous. That's also called a solution. So one of the things that's going to help you is having a flow chart for how you decide whether it's an element, compound, heterogeneous, or homogeneous. So this is the flow chart. So I'll leave this up here, and you can copy it down. But we have matter, and then you ask yourself, does it have just one ingredient? Okay. If it has just one ingredient, it's a substance. Okay. If it's multiple ingredients, it's a mixture. Okay. And then if it's made of elements, if the substance is made of elements, then it's a compound. If it's only one element, it's an element. Okay. And then mixture, is the mixture chunky? If it is, yes, then it's heterogeneous, and you can see it. Is it chunky? If you say no, it's smooth. It's also a solution. Okay? So having this can help you decide the type of matter it is. So I'm going to actually ask you questions about whether it's these four, or sometimes I may ask you if it's a mixture, a compound, or an element. But whatever. The point is that you can figure out from this flow chart what the type of matter is. Okay, everybody, have a good day.